Immersive photoreal innovative gameful pedagogy for e-Ophthalmology with 3D augmented reality. When COVID-19 happened, teaching in medical field shifted to e-platforms, with ophthalmology being no exception, with high demand for augmented reality. The 3D eye models were constructed with real ophthalmic images. Let us see why and how. The 3D eye models were constructed inside the Unreal Engine software, especially using true confocal fundus images for creating the posterior segment of the eye. Similarly, anatomical structures pertaining to ophthalmology, such as the cavernous sinus, was also constructed in a three-dimensional way. Unreal Engine was the software used to make the 3D models. This is a blueprint of the model. Inside the blueprint making software, you can see a white ball called the root, to which the 3D model is anchored to the AR template. Launching the IMG AR app. With the following steps, one can gain access to this gamification tool for infinite e-learning. Step 1. Download the AR template depicted by the red arrow and take a printout of it and place it on the table. AR template printout is mandatory for a successful AR experience. Step 2. Install the IMG AR app on your phone from the Google Play Store or your App Store. Then launch the app and focus your mobile camera on the AR template. The AR template should be fitted within the borders shown on the display screen for the activation of the AR model. This is an animation of the same process. Bring the mobile camera over the table and launch the app. Take a printout of the AR template and place it on the table. Bring the mobile camera to fit the AR template for the eye model to appear. By rotating the AR template, the eye model will rotate along with it. The AR template disappears when the camera is taken away from the template and reappears when the camera is brought back to the AR template. Move the camera accordingly to focus on various parts of the eye. Click Change Anatomical Structure button to view the next model. The user can access any angle of view of the 3D model by moving the camera accordingly. Real-time demonstration of the eye model in IMG AR. Here, the pedagogue is seen demonstrating the eyeball model in all the 360-degree angles to explain the anterior and posterior anatomical structures of the eyeball respectively. The left side video demonstrates the teaching class and the right side video displays the mobile view that the students visualize during the class. Customized multiple views of the same 3D eye model can be viewed by moving the camera accordingly for visualizing multiple angles such as top angle view, anterior segment and posterior segment view. For constructing the angles of the anterior chamber, we have used our patient's own real-time images as an inspiration for powerful deep teaching. All the 5 angle structures have been constructed in the AR model, from the root of iris posteriorly to the Schwalbe's line anteriorly. Similarly, for constructing the fundus, we have used our own patient's real-time confocal fundus images. Pathological fundi images are also used in the AR model, such as central retinal vein occlusion, branch retinal vein occlusion, and central retinal artery occlusion. This is a mobile camera live display while using IMG AR app. Once the app is launched, the normal eye model appears. By bringing the mobile forward, you can focus on the angle structures for AIOC-PI counseling and SLT counseling. By clicking on the splinter hemorrhage button, you can show how it looks in real time, which is a sign of glaucomatous progression, and the patient can be cautioned. Infrared images can also be accessed simultaneously. RNFL defects can also be shown to the patients in the augmented reality model. Multimodal imaging such as autofluorescence and infrared images can also be accessed simultaneously. Moving on to real-time demonstration of the cavernous sinus in IMG AR. Once the mobile camera is focused on the AR template, the 3D cavernous sinus model appears. The pedagogue can either rotate the AR template to view the model in all the 360-degree angles, or he can move himself to view the model in 360 degrees. The pedagogue can observe the cavernous sinus closely by moving the mobile forward. For pedagogical transformation, augmented reality models can open a new world of photoreal cinematic experience with gameful e-learning. 3D augmented reality is the future of e-Ophthalmology, especially during the COVID-19 era. IMG AR will serve as a new age immersive 3D pedagogical tool for gameful learning. It works both on Android and iPhone platforms. It is available free of cost and it is built on advanced 3D touch interface. To conclude, the neophytes no longer have to mentally visualize the ophthalmic concepts during learning. IMG AR is a powerful cognitive tool which serves as a 3D encyclopedia where students can choose their optimal frame of choice from the 360-degree angle for viewing. It also enhances the real world with immersive gameful learning experiences by providing a digital overlay over the real world. Thank you.